is a scary story. Scary stories make us nervous, make us think we don't know the math, right? Especially because we got this crazy word depreciates here. So we think, uh-oh, we're in trouble. But get back to basics. This question isn't about machines and depreciation, right? The answer choices make it very clear what this question is about. Do they remind you of anything, those equations? They're lines, right? There's no exponents, there's two variables, it's a line. So we want to think in terms of y equals mx plus b. Write that on your page. That's what getting back to basics is. It's taking an idea that you might have in your head, putting it on the page, and using that as a starting point. If it's in your head, it's harder to work with. If it's on the page, we can start to put things together and see how it might work. Now they've done some things here to my classic y equals mx plus b situation, right? First and foremost, they've changed the letters. So v is my y, and t is my x. They've also swapped these other two values, right? So they've put the b before the mx. And we know that because the m and the x are attached to each other always. The x, the t in this case, is going to be second, so that means that they've flipped the positioning of it. So we might want to do that ourselves and be like, okay, b minus mx, or mt. Now, we still need to figure out what b and m are based on this story. But because it's a line, and lines are lines, they don't change just because we've added a story on top of them, we know what b and m are supposed to represent. B is normally our y-intercept, and m is normally our slope. And when we have a story, we sometimes use different words to describe these two things. So for the y-intercept, we usually think in terms of a starting point, right? It's where when time is 0 or whatever we're talking about is 0, the line starts, because we don't usually have negatives when we're dealing with a story. And the slope is like a rate or change, right? So we're trying to figure out what that rate is. And so we have a starting point. That's the easiest thing to find in this question, right? A company purchased a machine valued at $120,000. That's our starting point. That's our B. It starts at this value. So anything that doesn't have a B as 120,000 we can get rid of. So that gets rid of A right there. Wrong value. But that leaves us with three choices. Now we need to find the rate. And the first thing we might notice is, well, is it a positive or is it a negative, right? Because we have one positive choice. And that's where that word depreciate comes in. It means something decreases in value. Now, if you didn't know that, you can still get that from context, right? Because it says that it goes from being 120,000 to 30,000. It's a decrease, right? So we don't need to know depreciate. It kind of says it just in the numbers. So a decreasing rate means we're going to have a negative slope. So that gets rid of C. This is a problem. This is a problem. And now we've got our final choice. What is the rate of decrease? Well, I don't see 9,000 anywhere in this question, so that doesn't look too good. But I do see 30,000. Here's the thing, though. Look at where we are in this test. We're at question 14 out of 30 multiple choice. What does that mean for us? That means we're halfway through. That means we're halfway through the difficulty. This is not a hard question. We're kind of like medium difficulty here. So is it really going to be 30,000? Is it really as simple as just picking the two numbers out of this question? Or is there some other step? Right? I'm at least nervous. And so here's a case where I would try to prove my answer as best I can. Well, let's follow our own advice from before. Let's get back to basics. How do we think about slope? Right? What's another way to think about slope? Sometimes we think about change in y over change in x. Slope. Sometimes we think about rise over run. We don't have a graph though, so we think about the more formal version of it. y1 minus y2 over x1 minus x2. We can calculate this slope. Right? When we do that, we normally have points, so there must be points here. Well, we know One of the points is that when time is 0, x is 0, the y is 120,000. That's what a y-intercept is. It's a point. It's a point where we know the x coordinate all the time. It's 0. So that's one point. And then after 10 years, the value is 30,000. That's another point, right? So that's 10, 30,000. Remember, they tell us what these variables mean. So we know just from the story, they tell us what they mean and what's our x and what's our y. So we have 2 points to plug into our formula that tells us the slope. You probably see where it's going, but I'm going to do it anyway. So that's 120,000 minus 30,000. I'm going to do it in that order so I don't have to deal with negatives. Divided by 10 minus, careful, I do have to deal with negatives, 0 minus 10. So 120,000 minus 30,000 is 90,000 over negative 10. Zeros cancel. I could do it in my calculator if I wanted to, but that is going to be a slope of 9,000 over negative 1, or just negative 9,000 is my m. Just make sure that's nice and tidy. And so there it is, negative 9,000 in choice B is my m. Proven. And yeah, you could have maybe taken some shortcuts, relied on your instincts, and gotten this a little faster, but I say it doesn't really take much more time to prove it, and I'd be much more confident if I could do that. So yeah, I would take the time here. But notice, we are still dealing with the same things we would deal with if we didn't have a story and we had line equations. We would just be thinking about slopes and intercepts. They have slightly different names when we have a story, but the formulas still work, the equations still work. Nothing has changed just because they put this story. And so you need to be confident that all these story questions have something else going on. If you can find out what that is, that basic idea that underlies the story, you can get back to basics, you can get back to familiar territory, and you can get back these points.